This video goes over pH, pOH, and concentration problems. And when we're talking about concentration problems, we're talking about either hydronium or hydroxide ion concentration problems. Okay, the first thing I want to do is go over equations. So on these equations, the first two that we're looking at are dealing with an acid. And we know that these are dealing with an acid because we have hydronium and we also have a pH. So there's two different ways that we can tell that we're dealing with an acid. Also, whenever we have hydronium ion concentration, we can also use a hydrogen ion concentration or an acid, or the concentration of an acid. So all three of those are interchangeable. The third equation is a great equation because we can use this with both an acid or a base. So depending on the question that we have, sometimes we have to have two equations, and we are more than likely going to use this equation as one of those equations. The last two equations on here are dealing with the base. And we know that this is the base because we have a hydroxide ion concentration, and we also have a pOH, which stands for the power of hydrogen. Now, when we have hydroxide ion concentration, that is also interchangeable with the concentration of the base. So you can have multiple things that relate to a base. Okay, let's do some problems. The first problem says, what is the hydroxide concentration of a solution with a pH of 9? So let's look at what we have and what we're being asked. So first of all, it's asking us, what is the hydroxide ion concentration? That's our question mark. And this goes with a base. And the only thing we're given is a pH of 9. So first of all, let's find the equation that we need to solve. So which equation, so which thing on the left is dealing with hydroxide ion? And the last equation says hydroxide ion equals 10 to the negative pOH. But the problem is we don't have a pOH. We only have a pH. So in this case, we're going to have to use this first equation because that has a pH in it to get us a pOH, which therefore we can plug into the second. So we're going to do this one first and this equation second. So the first thing is pOH plus pH equals 14. So we're just going to plug in our information. So right here, pOH plus a 9 that came from our question equals 14. We subtract 9 from both sides and we get a pOH that equals 5. Okay, that's all from our first equation. Now that we have a pOH, we can plug it into our second equation. So we're just going to say hydroxide ion concentration is equal to 10 raised to the negative pOH. We're going to exchange that pOH for 5, and that's going to give us 1 times 10 to the negative fifth, and concentration always is a capital M. So our answer here is 1 times 10 to the negative fifth molarity is our hydroxide ion concentration. Okay, let's look at our second problem. Okay, this says, what is the pH of a solution if the hydroxide ion concentration is 2.5 times 10 to the negative 6? Okay, we need to find the pH. So pH, we can either use this equation, or we can use this equation because this has a pH in it, and if we rearrange that equation. Okay, so that's our unknown, is our pH. We're given a hydroxide ion concentration, and this is dealing with the base. Okay, so on this one, because we have two possible equations we can use to find pH, we need to look at which equation goes with this hydroxide ion. So if we look down here, the only one that uses this hydroxide ion is this one right there. The pOH equals a negative log of hydroxide, and this is going to give us the pOH. So from here, which equation goes with the pOH or has a pOH? This one does. So on this example, we're going to use this equation first to find the pOH, and then we're going to use the second equation to go from a pOH to a pH. So let's go ahead and plug this one in. So pOH equals the negative log of our hydroxide, which is this 2.51 times 10 to the negative 6. If we plug that into our calculator, we're going to get a pOH of 5.6. Now that we have that pOH, we're going to use the second equation. So pOH is 5.6 plus pH equals 14. So from here, we're going to subtract our 5.6 from both sides. And then that leaves us with a pH of 8.4. And this makes sense because a pH of 8.4 is on the base. That's a base. And so remember, anything above a 7 is a base, and so that makes sense that that would be a base. Okay, next question. Okay, what is the pH of a 0.25 molar solution of KOH? So pOH is our pH is our question. 0.25 molar solution of KOH. This is dealing with a base, and this is a concentration. So again, let's look at what we have. We're trying to find a pH. So again, we have two equations that have pHs that we can solve for. We're given this hydroxide ion concentration, and so the only one we can use here is this one. So this is just like the last question. We're finding a pH, and we're given a hydroxide ion concentration first. So the first thing we're going to do is use this equation to find a pH, and then from here, if we have a pOH, the only one we can use is that one for a pOH, so we're going to use this equation and not that one. Okay. So let's go ahead and plug in our information. So first thing, we're going to use this first equation right here. So our pOH is going to equal the negative log of our hydroxide ion concentration. When we plug that in, we get a 0.6. So our pOH is a 0.6. Then we're going to use our second equation right here, number 2. So our pOH is a 0.6 plus pH equals 14. We're going to subtract 0.6 from both sides. Wow, I can't write tonight. And pH is going to equal a 13.4. And again, this makes sense because 13.4 is a pH of a base on the pH scale. So that makes a total sense. Okay, let's do a different question. All right, this next question says calculate the pOH of a solution that has a pH of 3. So what we have here is a pH of 3. We're asked to calculate the pOH. So let's look for a question that has pH. For a question that has pOH. So here's pOH and here's pOH. Given this information, we don't have a hydroxide, but we do have this pH. So we're not using this one. We're going to use this equation. And on this one, this is all we need to use. So we're going to go ahead and just plug in our information. pOH, that's what we don't know, plus pH, we know that's a 3 from our question, equals 14. Subtract 3, pOH equals 11. And that is our answer. So on this equation, we only had to use on this question, we only had to use one equation. And sometimes you'll get those depending on what you're given. Okay, let's do another question. This question says calculate the pOH. So there's our unknown of the following solution where hydrogen ion equals 6.5 times 10 to the negative 5th. Okay, so we're trying to find pOH. So pOH, we've got, again, two equations that have the pOH we could use. The first equation, we have to have a pH. we don't have a pH here. This is a concentration. The second equation that we can use has a pOH of a negative log. And we don't have that either. So on this question, what we're going to do is we're going to use this first equation to find a pH, and then from there what we're going to do is use the second equation, the pOH plus pH equals 14, because we don't have enough information to use that fourth equation. So let's go ahead and plug in what we have. So the first thing, this is number 1, number 2. So the first one is pH equals the negative log of our hydrogen ion concentration, which is 6.5 times 10 to the negative 5th. And once we plug that in, it equals a 4.19. So now we're going to use our second equation right here. And we're just going to plug in what we know. So we don't know our pOH, but we do know our pH is 4.19 equals 14. We're going to subtract the 4.19 from both sides. And our pOH is going to equal 9.81. And that is our answer. So that's how we find the pOH of this solution. Okay, I hope that helps. If you have any other questions, let me know. I'll be happy to help. Have a great day. Bye.